finding the restriction sites. So, now we are going to write a main program and see our code in action. Let's start with the pseudocode as usual to see what still needs to be done. First we want to get DNA. For this we use get file data and extract sequence from FASTA data. Then get the rebase data into a hash from the file BI-102. For this we use parse rebase function with BI-102. For each user query, if query is defined in the hash, get positions of the query in DNA and report on positions if any. Now we are going to write a subroutine that finds the positions of the query in the DNA. We can use a global search in a while loop as in given arguments $query and $DNA. While DNA equals the regular expression $query, save the position of the match and return that positions. The built-in function post function will solve the problem. It gives the location of the last match of a variable in an m//g search. Now we are going to see the main program followed by the required subroutine. It is a simple subroutine given the Perl functions like pose that make it easy. Program to make restriction map from user queries. We want to make restriction map from user queries on names of restriction enzymes. As usual, we are using strict and warnings. Then declare and initialize variables rebase hash initialized to empty and file data is initialized as empty array and the variables query, DNA, recognition site, regular expression and the array locations are used. Then read the file sample.dna. The statement will look like file data equals get file data with argument sample.dna. Extract the DNA sequence data from the contents of the file sample.dna. Then DNA equals extract sequence from FASTA data of file data. Get the rebase data into a hash from the file BI-102. For this we use the statement rebase hash equal parse rebase of BI-102. Then prompt user for restriction enzyme names and create restriction map. For this do print search for what restriction site or quit. The value entered by the user is assigned to the variable query. Then chomp $query and exit if empty query. If query equals regular expression space, then exit. Perform the search in the DNA sequence as if exists $rebase hash of $query, $recognition site and regular expression is called with split function space and rebase hash of query. Then create the restriction map with the statement locations equal to match positions of regular expression and DNA. Then we want to report the restriction map to the user. If locations is true, print searching for query and recognition site with the regular expression. Print a restriction site for query at locations and print join space and locations. Else print a restriction site for the query is not in the DNA. This will be continued until the $query equals quit. The subroutines used is find locations of a match of a regular expression in a string and return an array of positions where the regular expression appears in the string. For this we use the subroutine match positions. Declare variables positions as initialized to empty array and determine positions of regular expression matches. The while statement is used as $sequence equal to regular expression, then push positions pose of sequence minus length of $ampersand plus 1 and return positions. Here is some sample output from this program. Here the user enters some restriction enzyme name and searching for the restriction enzyme name in the sample.dna file and the locations if found are returned to the user. This will be continued until the user types quit. Notice the length $ampersand in the subroutine match positions. That $ampersand is a special variable that's set after a successful regular expression match. It stands for the sequence that matched the regular expression. Since post function gives the position of the first base following the match, you have to subtract the length of the matching sequences plus 1 to make the bases start at position 1 instead of position 0. To report the starting position of the match. Other special variables include $quote, which contains everything in the string before the successful match, and $closing quote, which contains everything in the string after the successful match. So, for example, within quotes 1, 2, 3, 4, 5, 6 equals and the regular expression 3, 4 is given, succeeds at setting these special variables like so. Dollar opening quote equal to 1, 2, dollar ampersand equal to 3, 4 and dollar closing quote equal to 5, 6.